Okay, we are on page 61. This is page 61 of your workbook, and it's lesson 7, unit rate as the constant of proportionality. And what it really is that we are going to start writing equations today. So we've worked with proportions, recognizing proportions in tables, recognizing proportions in graphs, and now being able to write those into equations. So this is the beginning of that. All right, so the first question is rather long. I'm going to read it out loud. You could read it with me. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? And so the first one says, why does it matter if the deer population is not constant in a certain area of the national forest? So you might want to write your ideas. If we were in class, we would brainstorm different ideas or theories about this. So you could pause and do that, or you could just continue going. That possible ideas might be for food supply, or overpopulation would be something that you might be concerned about. Or if there's too many deer, damage to the land, maybe. And then it asks, what is the population density of deer per square mile? So in order to do this, we're actually going to create a table with some of the information from the graph, being like this is the information, and here, and here. Okay, so if you create a table, like a rough table sketch of square miles, how about if we put an E on square miles, and that is X, and then maybe number of deer, okay, and if I do something like this, just creating a table, we have 3 pieces of information. I think I want one more column here so that I could do the math, the division of y and x. So if we say the number of deer is y, and square miles is x, and then let's just fill in our information here. So we have like 144 deer in a 16 square mile area. We have 117 deer in a 13 square mile area, and I'm just getting this information from up here. And we have 216 deer in a 24 square mile plot of forest. So if we were to divide these here, and this would be y divided by x, because that's to see if it's proportional, right? Because we'll get to that. Sorry, I don't want to keep going. We have 144. I'm going to do a slash instead of, well, if I could fit it, just so you don't get confused. Divided by 16. Having some issues today. 144 divided by 16. Y divided by x is 9. 117 divided by 13 is 9. You can check these if you don't believe me. 216 divided by 24 is 9. Okay, so now we have the unit rate of deer per 1 square mile is 9. So like I could say 9 deer. And what we do, or we referred to this as the constant in previous lessons. Now we're actually going to extend that definition or that vocabulary word to the proper math word, which is constant of proportionality. Okay, so we call that number 9 the constant of proportionality, and we refer to it as K. The constant of proportionality is 9. And I could go if I wanted to label that. So we've worked with it throughout many lessons now, just looking at the constants, so it's not like a huge step to just add the proper lingo there, okay? And then it says, explain the meaning of constant of proportionality in this problem. So you would just say, there are 9 deer. You're kind of restating the unit rate, but just in a word, like a way that people normally talk. So there are 9 deer for every 1 square mile of forest. And you're like, yeah, we already stated that. We stated that here. And yes, absolutely, I hope you're noticing that, because the constant of proportionality and the unit rate are the same thing. They're just different ways of approaching, or I guess labeling a problem. Okay, we also are going to find out there's a lot more words that mean the same thing as we go through math, specifically like in 8th grade, you're going to learn another word that is the same thing if you don't already know that. Okay, so the next problem, use the unit rate of deer per square mile, or y divided by x, to determine how many deer there are for every 207 square miles. Okay, so now we are kind of adding to the table, I guess, but really what we're doing, so if you were to think about it and you were to put your square miles there, it's 207, and then how do you get the number of deer? Well, you multiply by 9, because 16 times 9 was 144, 13 times 9, and etc. So for this particular problem, if you had 207 times 9, I don't know why I wrote it with parentheses, but it'll work, right? That's just 207 times 9, 9 times 207, which is 1,863. So there are 1,863 deer for every 207 square miles. And then use the unit rate to determine the number of square miles in which you would find 486 deer. 486. So if it's deer is here, remember we could divide by 9 or divide by the other number, but we know 9. So 486 divided by 9 is 54. So in 54 square miles, you'd find 486 deer. Okay? All right, so basically we're just doing the problem on the deer right here, and the problem that we are continuing. Actually, I still want to, sorry, got a little distracted by my dog for a second. The vocabulary here is very important to this problem. So if we review it, a variable is a symbol, such as a letter, that is a placeholder for a number, right? And then we have the constant of proportionality, which I already talked about the definition, but if you want to know it in words, it's here. And then in a given situation, it would be reasonable to assign any variable as a placeholder for the given measures. For example, a set of ordered pairs T and D would be all the points that satisfy the equation D equals R times T, which really is distance equals rate times time, where R is the constant of proportionality. This value for R specifies a number for the given situation. So what this is basically saying is that it's kind of teaching you to use this equation right here which is y equals the constant of proportionality times x, right, to do the problem. And so when we did the deer problem, we used that a number of times, even though maybe we didn't realize it. Like, we're using it here in a different format. We also used it up here, okay? So, I'm gonna pause this video, and on the next video, we are going to do lesson 2 and lesson 3, or example 2 and example 3, sorry. I'll handle my dog right